Hello. Hello and welcome to this video on example of the types module which we covered in last video. The theory was covered in last video, so if you have not watched that video, you should go ahead and watch those because of course we are not going to go through all the details of the theory. So here is the practical example. Note that it's quite big a script. If you look at it, it's 1300 lines. So it might be possible that we are not able to cover this entire video in one go. So we may need to split this into two parts. So first is basically none type. Now none type is a type, and the value none, which we use a lot in Python, is of none type. So this line 18 here is what is important, and this will be true. Okay, so let's run this. Python space type example.py. So you see, none is an instance of type none, and it is true. And also note that this type is, if you see line number 15, it is class none type. Okay. So that was the first example. Now we move on to second. So we comment this out and we comment here. All right, now we look at the second example, the function type and lambda type. So we have a simple function add here, which adds two arguments passed to it and returns it. And then we have a lambda, which takes an argument x and multiplies that argument with itself and returns that. Now we are looking at type of add, and it should be function type. And then we compare the add with the types.function type, whether it is an instance of that or not. And this square type is again mentioned here, and we are comparing it with lambda type. So the final test is whether function type is lambda type. Okay, so let's look at the output. Let me save the program and we run this again. So the type of add is function. The type of square is also function, and essentially function type and lambda type are the same type, that is of class function. So that is the function type. Okay, now we comment this out and we move on to next example. So we put this here. And, okay, so next is okay, we need add here. We do need add. Without add it won't work. Okay, so in the function add we have an attribute called, all right, underscore underscore code underscore underscore. Now we see the code object here and then the function name. Okay, and then we have the argument count and what variables it has and bytecode. So is it an instance of code type? So you see, we take the code attribute here. Okay, let's see how it works. So you see, the code attribute, if you look here, line 60, gives us this. It is a code object at some hexadecimal memory address in this particular file at line 31. So if you look at line 31, it is the beginning of the function. Okay, that is the code object. Now the function name, name is add. Okay, number of arguments arg count is 2. Local variables are a and b, and the bytecode of the code is given here. Okay, so is this code an instance of code type? So yes, that is true here. Okay, so that's what this was about, the code attribute. Now let's comment this out and we have here. Okay, I don't think we need add. If we need, we will enable it again. Okay, so we'll comment this out. A lot of time will be spent in commenting out and enabling in the code. All right. So now we look at another function, multiply. It has two arguments and it returns the multiplication of those two. And then we take the code attribute. When I say code attribute, it means underscore underscore code underscore underscore, and we put that into original code. Okay, and then we create an object of function type. So if you look at the signature here, it gives you the signature as well. Okay, that is the recipe of the language server gives you the code. So original code is passed here, and then globals, and we call it dynamic multiply. Then we call this dynamic multiply at line 6 and 7, and we expect the same result, that is 6 7 ja 42. That is, this dynamic multiply function should return the same object because the code attribute is passed here. So it should contain the same code effectively. And the type of this dynamic multiply should be function type. So let's see this in action. Let me save the file and we see this. So dynamic multiply gives us 42 as expected, and the type is function. And now we comment this out and we have this. Okay. All right. Let's see here. So we have calculator, we have method init, and we initialize the constructor with one value. The self is this pointer, and we have the instance value. The value is an instance variable, and when we add something, we return self.value plus amount. Now we create a calculator with 100, and we see what add does here. So it is normal bound method, and then we find the type of calculator method, which will be types dot method type. Now we define another function, subtract. Okay, now this is outside the calculator, note that. And then to the calculator subtract attribute, we assign this method type. So if you look at method type signature, it takes a func, that is a function, and an instance. Note that it takes an instance, not a class. So we put this inside calculator object, and then we have a dynamic call here, dynamically bound method, and we have subtract 30. So it should give us 70. And this should be 3 quotes. Okay. Now we run this and we see normal bound method is bound method calculator dot add. Its type is method. Is it a method type? Yes. Then we have dynamically bound method, and upon doing calculator dot subtract 30, we get 70. All right. So this was as expected, and we comment this out now, and we move on to next one. So let me comment this out. I don't want to run the entire script at the same time because it will produce huge output. Now we will look at built-in function and method type. So len is a method. So what is the type of len? So it should be built-in function type. Its instance should return true. Now suppose we have items and we look at items.append. We try to find the method append. So it should be built-in method type when we compare this. And finally, we find the types of built-in method and function type. So run this, and built-in function or method is true for len, and same is true for append as well. And if you look at the class names of built-in function or built-in method type, both are same essentially. Okay. Now we move on to the next one. So this time we have generators coming over. Okay. So we have a function numbers which is going to yield three values 10, 20, 30. So three successive calls should give us 10, 20, and 30 in that order. And we create a variable generator, and its type, if we see, should be generator type. This is instance should give us true here. And then we try to find out values in generator. So this should give us 10, 20, and 30. Let's see this in action. So as expected, generator is an object of numbers, and its type is generator. Is this generator type? Yes. And the values are 10, 20, and 30. Okay. Now we comment this out, and we look at, okay, we need generators here. So we can't comment this part out. We still need it. Okay. So yeah, right. So there are two things: generator function and generator object. So numbers, we have type generator function. We find its type, and then we call it. So calling should give us value 10. So we compare the function type of numbers, and then we compare the generator type. So when you call it, it becomes a generator. Otherwise, it's a function type. So let's see this in action. So as expected, the value 10, 20, 30. Oh, that was the old value. So we have 1, 2, 3, third value. So calling the generator function give us an object, okay, generator object here. And so the output is self-explanatory. We are looking at below this. So this is what we have. Okay. Next we have is coroutine types. Okay. So we have not covered async Python as such. Let me think if we should cover coroutines or not. I think we'll skip coroutines unless we cover the async stuff. It will be confusing. Async generator type also we will skip. We will go straight for module type. Okay. Give me a moment. So we comment this portion out. All right. So we have imported sys module here. So if you want to see, we have sys imported, and we'll go to that portion. Okay. So the type of sys would be a module. So it is of type module. And if you want to know its name, you can invoke the name attribute. And if you want to get the file one, then you have to get the file attribute here. Okay. So let's see this. So we have class module. Okay. Is it a module type? True. And the name of the module is sys. And the module file is built-in module. So we comment this out. We will cover async IO and coroutines once we cover the asynchronous programming. Now let's not there. So we will now have creating a module dynamically. So we create a module. My dynamic module is the name. So my module object is that. And we create objects like answer 42, message, hello from a dynamically created module. We create a function, and then we put that function as greet. So if you look at my module, it will be a module object. Okay. And then the name should be my dynamic module. Answer should be 42. Message should be a string. Okay. And it should, if we give us Python argument, it should print us hello Python. So as expected, the name of the module is Madanic module, and answer is 42. Message is what was there, and greet function when called uses hello Python. Okay, so this was the module type object, and then we have a namespace example. So simple namespace, we create a simple namespace object. So if you look at simple namespace object, it takes a mapping of table, okay, and then tuple of str type or any. So we have a table here. So name is equal to Alice, age is equal to 30, and city is equal to Delhi. Okay. So these three names are defined in this namespace, and we call this function a person. So person will be an object of types dot simple namespace type, and the attributes we can get name, person, name, age, and city. And we look at the dictionary of person, and we can increase the age, and we can add profession also, and then we print person again. So let's see this output. So it is a simple namespace object. Its attributes are Alice, 30, and Delhi. And the dictionary will print the attributes in name key value pairs. And after modification, age becomes 31 and profession becomes engineer. So pretty simple stuff. So it is nothing complicated is there in this entire script, just that there is a lot of code here. So okay. So we have a dictionary here. Now we have Alice and age in the dictionary, and we can get the name like so. And we create a simple namespace person object, name Alice and age 30, and we can get name like so. Okay. Simple namespace is useful when attribute style access is convenient. Okay. So you can choose either of these, there is no problem. Usually people use dictionary, so we can do that. So we run this, and the output is simple. Both names are Alice. Okay. Now we move on from this one, and we go to mapping proxy type. Now we need this. And we comment this out. Okay. So we have a configuration here. For example, host is localhost, port is 5432, which is PostgreSQL port, and database is production. And we create a read-only configuration from this configuration using mapping proxy type. And we look at configuration, which is the dictionary and the read-only view. Now we can access a value by getting the any key, host, port, or database. Now if you try to modify the read-only configuration by changing the port number to 5433, it will give you a type error. So we will look at the traceback here, what the exception is. Okay, we are not looking at traceback, we will look at exception. And then we look at the port property, important property. So original dictionary is configuration. So this configuration will have port number changed to 5433, and we'll see whether mapping proxy type sees the change or not. So if you look at the last part, which is the most important, that when you change the original dictionary to 5433, the mapping proxy type also sees this change 5433. Initial dictionary is this, read-only configuration is this. We look at host name, and when we try to modify the port number of the read-only configuration to 5433, we get the exception mapping proxy object does not support item assignment, and then we change the port number of original dictionary to 5433. So quite useful to maintain the configuration files and such. Then okay, we comment this out. Okay, so now suppose we have another dictionary 10, X is the key and 10 is the value. We create a view from the mapping proxy type of data. So we look at view, then we assign X and Y to 99 and 200, and we should be able to see that in the view. So as expected, we see the final view as 99 and 200. So let me comment this out, and we look at dynamic class attribute. Okay. Need to put it there. All right. So we have status as a class. OK is 200, not found is 404. And then we have types.dynamic class attribute. We have description here. Self.value is 200, then success. Self.value is 404, then not found, and otherwise unknown. And we have a constructor which we construct with a value. Okay. So we create an object status out of status class with the value 200. So here we look at the description of the instance. Okay. That is the object. Now, if you try to look at the description of the status class, we should have an attribute error, okay, which is dynamic class attribute hides the attribute when accessed through the class. The descriptor itself can be obtained from the dict. So from the class, we can get the description object. Let's run this. And as expected, we have the success here. The description is success. Okay, it returns this success here, and dynamic class attribute gives us an exception which we see, and the description object we have got from that. So it is an object of dynamic class attribute. So we are where? We are nowhere to med. Okay, we will look at generic alias and then we will end this video here. So next we will look at generic alias. So this example, I believe listInt was there in the documentation as well. So we have a list of integers by creating a list of integers. Now, if you look at the type, it should be generic alias type, and so list of friends will be generic alias, and it will have origin attributes and the args attributes. Then we create a dictionary type from strn to we create a tuple type, and we create a set type, and then we look at those objects. Okay. So here the type of the listInt was generic alias. Is it generic alias? Yes. Origin is list class and argument is integer, and other objects are treated as we expected them to be. So we will end this video here, and we will continue in the next video after 4 days, that is from constructing generic alias directly. Okay, we will resume at 19. So I think it is quite good midway 582. We are not halfway through it, but okay, we will cover rest of it in the next one. So it may be that we need 3 videos to cover this, but I don't want to cover a lot of material in one video. So we will continue from this construction of generic aliases directly. So I hope that you enjoyed this video and got something to learn. Note that you need to watch the previous video, otherwise you won't understand all this. The types module read through of the documentation. So with this, I will end this video here, and we'll meet again after 4 days and we'll continue this program. So thanks a lot for watching the video. Keep learning, stay curious, and most importantly, enjoy.